Hi everybody. In this video we are going to cover the post-mortem changes that happen after someone dies, the pre-embalming changes. So post-mortem changes happen after someone has died, after somatic death has taken place, so the death as a body as a whole. The extent of these changes depend on the period between death and embalming. The longer you wait, the more of these changes are going to happen, and they'll start to overshadow things that happened in the antemortem period. Embalming is designed to slow these changes. Again, it's not designed to stop them because we can't, not the way that we embalm. It's just designed to slow them so we have the temporary preservation. So we can divide post-mortem changes up into physical changes and chemical changes. The physical changes tend to indicate change in location of something. Could be heat, could be fluid, whatever. But think of the physical changes as changes in location. The first one is algor mortis. That's postmortem cooling of the body. Now we saw agonal algor in the antemortem section. Again, algor means to cool. Agonal means beforehand, before death. So agonal algor is cooling of the body before you die. Algor mortis is cooling of the body after you die. The body's always going to cool to equilibrium with the temp of its surrounding environment. So people always think the body cools. Well, not necessarily. If a body dies outside and it's 110 degrees, the body's actually going to warm up to 110 degrees. If they die in an environment that's 40 degrees, then the body will cool down to 40 degrees. Now, they do actually use body temp to kind of indicate time of death. Now, they do that by taking 98.6 degrees minus the rectal temp, because that's core temp. They might even actually use almost like a meat thermometer and stick it in the liver, because that tends to retain heat a little bit better. So they subtract the rectal temp from 98.6. They divide that by 1.5 degrees Fahrenheit per hour, and that's the approximate time of death. Now, they don't always do that, but that is a way that has been used in the past to determine time of death. So what they figured is that the body temp will drop about 4 to 5 degrees per hour initially, then eventually it kind of slows down to about 1 to 2 degrees per hour. And again, it just kind of depends on the environment also. Now, there's different ways that a body can lose heat in general. There are three vehicles, if you will, of heat loss. One is conduction. That's energy movement through material. It's the result of you touching something. So when you touch a tabletop and it's cool, well, eventually it's going to heat up. The reason it's going to heat up is that you are touching it and you are transferring your heat to the molecules of that table. And this is a result of a collision between molecules. So the high energy molecules of the warmer material, i.e. your hand, will transfer energy to the molecules of the cooler material, the tabletop. So that's conduction. It's done by touch. Radiation is through electromagnetic waves. So the electromagnetic waves move through a vacuum. Radiation is like you warming your hands on a fire. You're not touching the fire. You are just feeling the warmth from it. Well, that warmth is electromagnetic waves. And then there's convection, like a convection oven. Convection is when warmer material displaces cooler material. So like warm air displacing cool air, warm water displacing cool water. This happens in coolers. So when you shut a cooler door, there's a fan inside, and the fan circulates cool air, and that's going to displace the warmth of the body, cools it down. Convection ovens kind of do the same thing. They circulate warm air, makes things go faster. Now, there are factors that can affect the ability of a body to lose heat. There are intrinsic factors and extrinsic factors. The intrinsic factors of algor mortis would include ratio of the body surface area to body mass. So more surface area equals quicker cooling. The more surface area you have, the more you can touch through conduction, the more area that convection can flow across you and take your heat out. So kind of the bigger the area, the quicker the cooling. Now, that being said, More body mass equals slower cooling because more body mass will insulate the body and retain that heat longer. So if you're really tall and thin, you will cool down fairly quickly. If you're short and stout and have a lot of body mass, you will cool a lot slower. Also, the body temperature at the time of death will affect the ability of the body to cool. So higher initial body temps, it's going to cool down to equilibrium with the environment a lot slower. If you have a low body temp, then you're going to cool down quickly. You'll get to that equilibrium much quicker. The extrinsic factors of algor mortis would include body covering. The more body that is covered, the slower they will cool. That insulates the body. A naked body will cool very quickly, whereas a body underneath a lot of blankets will retain that heat for longer. That's why you wear blankets. Also, the surrounding environment. We mentioned that before. A body will cool to a cooler environment. A body will actually warm up to a warmer environment. So it depends on what the temperature of the environment is. That's one of the reasons why we indicate that on an embalming report. Now, when the body cools down, so the effects of algor mortis, it can slow down the onset of rigor. Rigor mortis is a chemical process. It will slow down the onset of decomposition, which is also a chemical process. So cooling those things down make those chemical processes take longer. Again, cooling the body also tends to keep the blood in a liquid state. Now that can be good for us in that it will be easier to push that blood out during embalming. The cooling or the keeping of the blood liquid, though, can lead to more excessive cadaveric lividity, which we'll see here in a bit, which is an intravascular hypostatic blood discoloration. And if it sits in a cooler for a long period of time, it will create more postmortem stain, which is actually an extravascular blood discoloration. But the good thing is when you put them in the cooler, you put them on their back. And so if those discolorations show up, it tends to be on the back of the body where nobody will see it. So the next physical change would be hypostasis. We saw hypostasis before. We called it agonal hypostasis. Hypostasis is the intravascular blood movement to the dependent areas of the body. Again, it's intravascular. It's inside the vascular system. Anything that would impede the intravascular areas, such as clots or arteriosclerosis, may impede your hypostasis. But this is caused by gravity. So it's however the body is situated will determine where that blood and other bodily fluids start to gravitate to. Now, one of the things with this blood movement is wherever it goes, it's going to cause what we call cadaveric lividity or postmortem lividity. But if the body is actually touching something, that can lead to contact pallor. Contact pallor are pale areas where blood movement has been impeded. And you can see this if you kind of press your thumb into the palm of your hand and let go. It's very pale until the blood rushes back into that area. So contact pallor tends to be more on the back most of the time than on the front of the body. And again, because it's a phenomenon of hypostasis, it's intravascular, we can flush this out of the system. Factors that can increase hypostasis: thin blood, so bodies that have been on blood thinners or have excessive amounts of blood, you'll get a lot more hypostasis with that. Liquid blood will also increase your hypostasis. So you tend to see the hypostatic blood discolorations on the back of bodies that have been in coolers for a long period of time. So the main physical change that happens because of hypostasis is something called livor mortis, or postmortem lividity, or cadaveric lividity. This is an intravascular hypostatic discoloration. Again, it's intravascular, it's still in the vascular system, it's caused by gravity, so hypostasis, and it looks like a very dull bruise. So it's not this scrape here, that's not the lividity. It's all of this very dull purpley stain. Again, not quite a bruise, it's not as vivid as that. It's just an accumulation of blood in these areas. And notice the areas around it are kind of pale. That could be contact pallor. So the time frame for livor mortis is it tends to show up about a half an hour to 2 hours after death. It could be It could show up before they're even dead. Again, it can be agonal hypostasis causing this. But if it's caused by death, it's about a half an hour to 2 hours. Again, it's going to be affected by blood volume. If you have a lot of blood or even normal blood, you'll get quite a bit of livor mortis. If the person exsanguinated or bled out due to hemorrhage, then there's not going to be a lot of livor mortis because there's no more blood in the body. Blood viscosity will also affect it. The thicker the blood, so the higher the viscosity, the less livor mortis you'll get. And this can be corrected with embalming. So this is an intravascular discoloration, which means you can flush it out as you start to pump in arterial solution. So another phenomenon that can happen due to hypostasis is postmortem dehydration. That's, again, dehydration is decrease in body moisture. There's two factors that can increase dehydration. One is surface evaporation. So if the surface of the body is exposed to air currents, that passage of the air currents over the body surfaces will increase the postmortem dehydration. That's why when you put bodies in coolers, they should not be wrapped in sheets. Sheets can protect the body from this surface evaporation or convection, as we kind of talked about, as long as they are dry. But if they're wet, then it will actually wick moisture out of the body, making it dehydrated even faster. When you put bodies in a cooler, you should wrap them in plastic. That helps to protect them from that surface evaporation. The other factor that can lead to postmortem dehydration is hypostasis. So as the body dies and the heart starts to slow down, the fluids of the body will start to gravitate. And so as it gravitates down to the dependent areas of the body, where it came from will start to get dehydrated. Not overly dehydrated, but it can lead to some dehydration. And it's the hypostasis, the postmortem hypostasis, that can lead to postmortem edema in the areas where that fluid goes to. So the postmortem edema is the increase in body moisture. Again, this can be caused by hypostasis. So as we just mentioned in the postmortem dehydration, as the gravitation of the fluids take them to the dependent areas, where they came from get dehydrated, where they go to get edematous. Could also be caused by something called imbibation. Imbibation is the ability of proteins, especially, to draw moisture in from their surrounding tissue. Now, this could be due to the body being in water, and so as it starts to suck in moisture, it's going to swell the body up just through osmosis, through this imbibation property. The next physical change is increase in blood viscosity. Again, viscosity is the ability of one layer of a liquid to pass over another layer, i.e. its thickness. So blood viscosity equals blood thickness. High blood viscosity, thick blood. Low viscosity, thin watery blood. As the body dies and as it kind of sits and waits for embalming, the blood is going to continuously get more viscous. It's going to increase in viscosity. Now, this could be caused by dehydration. So if the body had agonal dehydration or postmortem dehydration, that the blood in those areas could become thick. It could be caused by hypostasis. Again, the liquid portion of the blood can start to move to other areas where it could leave some sediment behind. The effects of increase in blood viscosity would be that it's going to decrease your distribution and diffusion. It may or may not decrease your drainage. It's possible. If it gets so thick it's hard to push it out, that's possible, but it's less effective on drainage. Your distribution, it could increase that if there's blood still in the arterial system, which doesn't happen very often. What it tends to affect mostly directly is your diffusion. It's hard to get that thick blood out of the capillaries to be able to get your diffusion. It can also diminish livor mortis. Because the blood is thick, it's not going to gravitate as much, and so you don't get that postmortem lividity, that cadaveric lividity, or livor mortis. Another physical change is the endogenous invasion of microorganisms. Now, we kind of talked about this while someone was dying in the antemortem period, that translocation of microorganism. This is going to be even worse because now the normal mechanisms of the body that keep microorganisms where they are pretty much completely gone. And so they really start to move about 4 hours after death. And within about 24 to 30 hours, you have 3 times 10 to the 6th to 3.5 times 10 to the 6th organisms per milliliter of body fluid or per gram of body tissue. That's about 3 million to 3.5 million. So it's a lot. And that is going to affect your ability to disinfect the body. So the longer you wait, the harder it is to disinfect the body. Now, this could have real big problems if it has Clostridium perfringens in it. If you remember, Clostridium perfringens is what causes tissue gas or gas gangrene. This Clostridium perfringens, if it's not treated, if it's not destroyed, can make bodies unviewable within 1 to 2 hours. And now that kind of depends on some certain factors. Obviously, refrigeration will slow that down. But if you get this into a body and you don't embalm them right away, they're going to split like an overcooked hot dog fairly quickly. And that happens pretty quickly in a living body. Now, this microorganism is anaerobic, meaning it doesn't like oxygen. So a dead body is a perfect environment for it. So it moves very, very quickly. So those are all the physical changes that happen post-mortem. In the next video, we're going to cover the chemical changes that happen post-mortem.